AI Workflows with Jay Tower.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that AI, Azure, and the .NET ecosystem has to offer. I have a returning guest on the show. It's Jonathan Tower, or Jay, known by his friends and colleagues. He's a founding partner of Trailhead Technology Partners, a custom software consulting firm with employees across the U.S., Europe, and South America. He's a 12-time Microsoft MVP award winner for .NET and a Telerik developer expert. Jay brings nearly 25 years of industry experience with roles from senior architect to director of development. He was recently elected to the .NET Foundation Board of Directors for the 26-27 term. He's also a driving force behind Beer City Code, which is in Western Michigan, a large professional software engineer conference. Jay is also a LinkedIn Learning course author and an active speaker at software conferences around the world, being a speaker at the most recent .NET Conf. Jay, welcome back to the show. How are you, sir?
I'm very good. Thanks. It's great to be back. Thanks for having me, Jeffrey.
Oh, my pleasure. My pleasure. You've been on the show multiple times before, episode 263 and 371. If anyone wants to go in the archives, we'll include a link to that in the show notes. But before we get into our topic, I just kind of want to ask for the listeners who maybe are getting to know you for the first time. You've topped out over 2 decades in computer programming and getting computers to do interesting things. What is it about computers and writing code for them that just keeps you interested?
Yeah, I love that question. I was at a conference recently and some speakers were talking about this, and especially in the scope of AI and how it's changing what we do. And one person said to me that they have this theory, which I think there's something to, that there's kind of 2 groups in software engineering. There's the people who just really love the software architecture and getting the code just right and really cool just patterns. And I think I've been that in the past. And so I have that foundation. But at the core, through my whole career, what I've really loved about it is what he said was the other category, which is people that just want to solve problems for other people with technology. And his theory was that in this AI era, that second group, the one that I think I'm probably in, is going to do quite well because they're going to just be able to leverage AI to solve even more problems, even faster for people. And then it's going to be maybe a little bit of a struggle for that first group as they kind of try and adjust and figure out if they can shift when AI is typing faster code than them.
Yeah. One thing we were talking about before the show, technology has always advanced and there's new things. But even in doing so, some of the people fear-mongering, it's going to do all programming automatically. No industry has ever seen its engineers go away. Its engineers just kind of do different things.
Right. You probably have seen this too. I think we've had similar length careers. There keeps being new layers of abstraction. I don't know if you remember 4GLs that were kind of around in the 80s and 90s.
Well, I remember learning about them. I never used them.
I never used them either. I was told in college that this was going to basically, this is the future. You're going to just write English to these languages and they're going to figure out what to do. And that it might mean software developers go away. So this story is an old story. Obviously, it's way more efficient now with the AI LLMs we have today. But yeah, layers of abstraction keep getting added. We just keep doing different things at those higher level layers of abstraction. Nobody's writing machine code or assembler code or anything anymore, right?
Well, you've been thinking about how to use AI in the developer workflow and to use it really well. And you've written some pretty cool blog posts. One of the recent ones around how to use some specifications, whether or not it ends up being called spec-driven development or not. You've been thinking about what is a really effective way to get these language models to save us the most time and be most effective. So let me just ask, what have you learned that you're already, okay, now I'm putting this into practice because this freaking works.
Yeah. So at the risk of now sounding like one of those people who's all in on AI and thinks it's going to be taking all of our jobs, I think that AI has touched every single part of the software development lifecycle at Trailhead and significantly improved it, or at least changed it in ways that are like we're never going to go back. So you mentioned spec-driven development. There's this tool or library called SpecKit, which is basically like an opinionated way to do that. And I think that's a great place to start if you don't know where to. Jeffrey, you've got a consulting company. I've got a consulting company. I would say part of what we offer to our clients is a process, like a thought through, proven process for how to get from point A to point B successfully, especially in software where that's notoriously difficult to do on time and on budget. And so I think what I've found is investigating that is that SpecKit is great if you don't have a process, sort of like Agile forces a process on companies that don't have one already.
Mm-hmm.
But just like Agile, it's really great to then customize that to what your actual specific needs are. And so at Trailhead, we've kind of ended up creating our own, something probably pretty similar to SpecKit in a lot of ways, that is built more around our process and what we already bring to the table when we come to a new client.
So in your blog, you had a project where you were looking at maybe 20 to 60 hour projects, and then it went down to just a number of single digit hours.
Yeah.
Can you illustrate, like, that sounds like a lot. One, did that really happen? And two, how did it happen?
Yeah. So you mentioned Beer City Code in my intro. It's a conference that I help run. It's a totally volunteer run thing, so nobody gets paid. But as you can imagine with that type of an organization, there's a lot of things that don't make the cut from a budget perspective. Like, it would be nice to have X, but that's too much money, too much time, too much effort, too much maintenance, too much something, right? And there's all kinds of tools that we would have liked to have over the years to help automate processes, especially as a volunteer run thing. Like, the less work the humans have to do, the better, right? And one of those tools was this thing to kind of automate our raffle drawing process throughout the event. And that was what I wrote this blog post about. And it was something that was kind of hanging over my head for the last probably 7 years, where I was like, I'd really love to do that, but I can't rationalize spending a week and a half, 2 weeks full-time developing something that's only going to save me a few hours, a couple hours, maybe every year. It just, the math doesn't work out, right? But then when I started working with AI, around the beginning of this year, end of last year, to do AI assisted development, I was like, I can do everything a lot faster. And it all of a sudden, boom, it unlocks all these things that now have come down at least an order of magnitude in effort. So yeah, legitimately, I did that project in 4 hours. And I think realistically, it would have been probably 60 hours before.
So, no, admittedly, some of the listeners are probably saying, yeah, but this was a small website project. But even so, sounds like, and you mentioned acting like a general contractor instead of writing any code. How much code did you have to write yourself, fix yourself?
Yeah. So I reviewed the code. In that case, I reviewed, let's just say 75% of the code. There were certain changes where I'd say, hey, the CSS style is messed up, and it would go fix it. And I would say, yeah, it looks right. I'm not even going to look at the code. I'm not worried about a security vulnerability with CSS changes, right?
Mm-hmm.
But I did look at the majority of the code, and I wrote basically none of the code. I basically wrote 0 lines of code. Because what you learn when you start doing this AI-assisted development is that it can also fix things a lot faster than I can. So I just became a very knowledgeable, project manager, software architect, and stakeholder, essentially.
Okay. Do you remember how many lines of code roughly it ended up being?
It's a good question. I don't have an exact count. I can tell you, screen count is maybe 5 screens. So it's not huge.
Very small, right?
Yep.
So if AI is going to impact everything, then certainly it has to get the easy things right with no drama, so that we can really put it in super hard situations. So it's great. Tactically speaking, what tools were you using? What models were you using?
So for that particular one, I used GitHub Copilot. I'm probably have a slight preference for Claude code, and that's probably what I use the most, but I wanted to diversify a little bit. So for that project, I actually used GitHub and got just a fantastic result. So no problems there. For the people who say Claude is better, maybe that's true, but I was able to get just exactly what I needed from GitHub as well.
So with the price of tokens going up and probably continuing to go up, everyone's wondering, okay, how do I get the most out of it? Do you recall how much you got charged?
It's a good question. It took me 4 hours. And at the time, I'm trying to remember as an MVP, I think we get, is it the $20 a month, I think, package that we get by default on GitHub Copilot? I think that's correct. So I was on that plan and I was able to complete it in a single day. And it all fit within, my tokens.
Great. Okay, so extrapolate this. I mean, this is one of the simpler things. But when software grows, invariably, things become harder. Things break, and so what aspects that were similar here also work in more complex projects, or going into a code base where it's been around for years and years and years, and now a language model is not seeing greenfield or is not seeing consistent patterns in every section of the code base. What types of techniques have you seen being useful in those brownfield pieces of software?
Yeah. So something that, keep in mind, this is all kind of cutting edge, right? And changing every couple of weeks. So by the time this video goes out, there may be different answers to this, which is fine. But right now, what is kind of at the cutting edge is several months ago now, markdown files, thanks to Anthropic, started becoming kind of a major way to capture context. So there was a very brief time period there where a bunch of companies started standing up MCP servers that would let you get access to their documentation or their language specifications or whatever. And people would start including those. And what people quickly found was that those MCP servers use up a lot of your context. Like they would get contacted a lot, and a lot of information would go into your context, and you would very quickly able to have everything you needed in context. And so Anthropic had come up with this idea for Claude to create, first it was a Claude MD file, and now there's like 1,000 of them, different types of MD files. But we're actually finding at Trailhead what works really well is, and it's funny because it almost seems like it's too simple to work as well as it does, but to basically summarize, and you can actually have the AI help you summarize the things that you want it to know about while it's doing certain tasks. And we've sort of created like a hierarchy of these MD files. And so there's the main one that we try and keep as light as possible and kind of just point to other MD files in the same folder structure that say, if you want to know about this, if you want to know about front end web, look here. If you want to know about back end, or .NET or Azure or whatever it is, look here. We might have like coding standards in one, and we might have like our PR our pull request comment standards or process in another one. So all of those things are kind of broken out in our process into different files, and then they're all kind of rolled up in a hierarchy so that the AI can easily find them and reference them whenever it needs to. Another thing we started doing recently, which I think is kind of interesting, is you start putting in those files things that you ask the AI to do that tells you whether or not it read that file at the right time. In other words, you might say, here's what the architecture of an API endpoint in this application should look like. You might, in that MD file, you might put whenever you apply this rule, add this comment to the top of the file. Right? And now when you're looking through your code, you don't have to just kind of understand the code and say like, is this really the way I told it to do it? You can actually look and say, oh, yep, it used that rule. So I'm fairly confident now that when I look at this code, it's going to be implemented the way I told it to.
Yeah. It's really interesting with when ChatGPT came out in 2022, everyone was amazed and like, wow, we do it. Like it knows something. And then we kind of realized, man, it told me something completely fabricated or totally got the wrong answer. It doesn't know anything. And you mentioned the markdown files to teach this tool how to do things. And so I think the whole industry we're trying to get our mental model for large language models. What is it? What is it really? the core technology is an attempt at mimicking the way an actual biological brain works with neurons and links between them. But it's almost like it's a model of the structure of the brain with no knowledge, and there's some base training, but it's almost like Neo in the Matrix. He gets plugged in and then he says, "I know kung fu." It's almost like you walk into this LLM walks into a fight, and then immediately you have to teach it kung fu. It learns really quick, and then it can do some moves. But then you move into another area, and it's forgotten. There is no memory. It doesn't know kung fu. It's almost like whatever training and knowledge, it's almost like it has to be pushed in before the task, and then it totally blanks out on the next one because it's just a stateless algorithm. And so are we gonna have just all these different massive amounts of little bits of documentation that we just have to funnel in? I mean, is that the way it's going to work?
It is funny. And, right now it feels worth it. And I imagine as it gets better, it maybe even feel more worth the effort. But it is kind of funny, and it's easy to anthropomorphize the AI and be like, hey, I already told you, don't use M dashes in this thing you're writing for me, right? And 5 minutes later, it's putting M dashes in again. It's easy to anthropomorphize that and be like, you're so stupid. Like, why are you not listening to me? But when you think about it as essentially a word prediction model, it's easy to understand, like, it has had to summarize our conversation up until this point, and it kind of summarized that out of memory. And now its word prediction model is not using that instruction anymore. And so that's where these skill files, even though they seem really counterintuitive if you think of the AI as a human, like, why would you need to do this? But it's a really great way to kind of permanently capture things like that. So if you have like a writing skill that you create and say, never use M dashes. Now, if you document it correctly, if you use something like Claude, it's going to find that writing style and say, oh, I'm writing something right now. I should look at this writing style. And it's going to reintroduce the idea of avoid M dashes every time you start writing something. It's very powerful and somewhat counterintuitive.
Yeah. And the stateless nature, it has to load it back into context literally every time.
Every time, which is why you're paying for so many tokens.
Right. Now, which model have you grown to use? There's so many models out there now. Which ones are you getting the fee from?
Yeah. So for programming, Opus is fantastic. Sometimes I like to use Codex for programming tasks. A great thing you can do is kind of an antagonistic model where you use two different models to check each other. So you could say, basically, hey, Codex, or hey, Opus, do this programming task. And then you could say, hey, Codex, how did Opus do on this task? Are there security vulnerabilities? Is it following our coding standards, et cetera? That's very beneficial, but it's hard not to think Opus is the best. The latest Opus at any time hasn't been the best model for the last probably 4 or 5 months here. I do like a feature of GitHub Copilot, which is auto mode.
Mm-hmm.
Engineers don't usually like to let their tools make decisions for them, but I have found that from a functionality perspective and from a saving tokens perspective, that feature works really well. When I ask a simple question, if I go back and look, I can see that it's using a simpler model. And then when I ask another question that's like a big plan this feature out and follow my existing architecture, it'll use a more complex model like Opus to do that work. And that's a really nice way to just switch back and forth. And it's one way that I don't think Claude is as good right now. It's harder to do that in Claude.
Yeah, let it choose the model. We still have another 12 days before the GitHub price increase, or to go to the token billing versus the premium requests.
Yeah.
And I'm sure, like you, I've all figured out how to do larger and larger prompts on autopilot, or get Opus 4.6 to work for 8 hours on 3 premium requests. And so who knows how many tokens that was, but that days are over. And then it's going to be the question about, okay, which model could have done it? And I've gone back and done some experiments, even on some of the ones that are like the mini models, and realizing, man, okay, I could get certain types of things done on one of these mini models that are super, super cheap didn't have to have max reasoning. So, I mean, none of us know, but I think that wall of price increase is going to cause everybody to start experimenting and figuring out, okay, I guess I can't use the Ferrari to go to the grocery store.
Doesn't it feel like we have these kind of pendulum swings in the software industry periodically where there's a new technology and everyone goes all in on it, and then they're like, maybe we need to be a little more efficient. Maybe we don't want to have all this stuff in memory. I think of even like how we programmed web applications back in the day. It was like, oh, let's just do it all on the server and produce finished pages. And then it was like, maybe if we want more than 100 users on this application at a time, maybe it would be good to push a little more of that to the front end to do.
Right.
And back and forth that goes. But yeah, I think we're definitely in that era where the free ride is over with AI. So we're going to have to figure out how to be more efficient. I think local specialized models, maybe something in the future. There'll be like a model you have on your computer that knows JavaScript and one that knows C# and one that knows, all these different things that you're using and kind of weigh in on different topics. That would be great.
Well, so there certainly is the, proof of concept or small application. I mean, there's stories all over the place, but now let's get to the professional software development lifecycle where not even any person on the team, the software is big enough to where we don't really remember how every piece of the software is put together. I think I estimated one time that like our brains, if we were to translate it into a context, would be 100 million tokens at least, if it was the equivalent capacity of our own brain. So, okay, well, we're not anywhere close to that.
Yeah.
Plus, how many years of training and memory, we've lived.
Right.
So we can only get this slice into this, LLM call. And so with continuous integration and the software development lifecycle and all the stages that we've learned over the years to typically go through, how does AI change that? Or does AI cause us to merge some of those stages?
That's a really interesting question. I think probably the answers to them in short are yes, it changes everything. I think for those that will allow it to. There's certainly people who are kind of stuck and are not willing to change. And I think they're going to get passed by the industry. But then the answer to your second one is does it allow things to be merged? And I think the answer to that is yes, probably too. It's not clear exactly what that means yet, but I'll give you an example. Probably starting 10 years ago when I started Trailhead, started getting further and further away from being a front-end web developer. At the beginning of that era, I would say I was pretty decent at it. And now 10 years plus later, I would say I'm very mediocre minus at it. And it's just hard to keep up with everything, right? You can't be an expert on everything. And eventually, Trailhead started growing and we started hiring people and that stuff was delegated to them. And it was like, great, now I don't have to know that stuff. I'll know the high level stuff so I can help clients make good architectural decisions. But if I actually sat down and tried to create a good React app from scratch, I wouldn't be very good at it, right? Well, now with AI, I find myself being able to write pretty decent React code and even understanding it a lot faster. I can basically say, hey, these are the things that I've heard my team talking about. I want to use these tools. I want to use this architecture, maybe even look at this code base that they built to mimic the design patterns that they're using, and then explain it to me so that I understand why it's the way it is. And now I can kind of do web development that I didn't really used to be able to do. Same thing is applying DevOps. There's some DevOps tools that I know quite well, and there's other ones that I didn't know as well. And now I feel like a superhero. With AI, I can come into absolutely any DevOps tool and be like, boom, first try, I made a new pipeline and it worked, right?
Nice.
My joke with Azure DevOps 10 years ago was that it took about 20 builds before I got my first successful build. And now AI and I work on it together. I tell it what I want it to accomplish. It writes the YAML or whatever for me, and boom, off it goes, and it works on the first try. That's like a superpower. So what's the long-term effect of that? I think TBD.
Yeah. Well, the software development lifecycle that was taught when I was in computer engineering was requirements, analysis, design, development, and you get multiple types of testing and releasing. So with spec-driven development and then coding, it almost seems, I don't know what your view of it is, it almost seems to pull some development activities all the way up in requirements and kind of simplify that, or almost as if it simplifies it to figure out what to do and then do, as opposed to requirements, then analysis, then design, and then do. How do you think of that?
Yeah, that's really interesting. I haven't thought about that a ton yet, but as you're talking about it, it's making me think some things. I don't want to say Agile is going to go away or anything like that, because I think there's a lot of things that are great about Agile that are probably forever. But, take that example of that 60-hour project that I did in 4 hours. If I was going to do that over 60 hours, which probably would have meant as a volunteer that it would have been spread out over many weeks, I would have probably approached that very differently than if I could just sit down and do it in 4 hours, start to finish. It's now in production and running, right? So that makes me wonder, does that change? Like Agile is a response to a lot of things like, hey, we get off track when we go for 6 months on a project aiming at a particular goal and then realize that the goal has actually moved, but we haven't moved. But what happens if you go 10 times as fast? Or projecting into the future, what happens if you can go 100 times as fast? Mm-hmm. Does that matter as much anymore? I don't know, but I suspect something about those processes will have to change to catch up to it, because they were created for the particular world that existed when they were created, and it's a different world now.
Yeah. Well, you mentioned going 10 times as fast. With the previous guidance on continuous integration and just having a private build that we run locally, it's books and articles. Make sure your build is less than 10 minutes. And I'm thinking, man, 10 minutes seems like a long time with this faster cycle. Uh-huh. And when you want to have like one of these markdown files, instructions, okay, AI tool, whenever we're getting to the end of the task, run this private build, make sure it works. There's probably something wrong that has to be fixed.
Yeah.
10 minutes seems like a long time. How do you think about that?
Absolutely. That actually makes me think about something that I've been thinking about a lot recently. It sounds like maybe you have been too, which is the psychological effect that these tools are having on people like us who are using them. I would love to do a talk about it, gather some more data and do a talk about it at some point. But I'm noticing a lot of things, just like when the internet came out and all of a sudden for the first time you could order things on places like Amazon and have them show up at your house a few days later. Then we created this whole generation, like my kids' generation, that isn't used to having to wait for things. You remember when cereal boxes had a thing you could send off for, and it was always 6 to 8 weeks, and you would think about it, like every morning you would look at your cereal box and think like, oh, I wonder if that thing I sent off for is in the mail yet, or and you anticipate it. And now, can you imagine like this kids' generation waiting 6 to 8 weeks for anything? That's unheard of, right? I wonder what the psychological effect of basically being able to tell an AI, do this, do that, do this, do that, and having it just do stuff, maybe even multitask like crazy, and then to turn around and have to deal with humans again that are at human speed, that can't type, 1,000 pages a minute and so on. Anyway, that's kind of what it makes me think, is like, what's the psychological effect of all this on us?
Yeah, interesting. Well, let's talk about the psychological effect of a whole bunch of AI-generated code that you realize is just a big old pile of garbage and having to shovel our way out of it. So I think with anybody who's done experimenting, there's been painting into a corner where it's like, oh, shoot, this is just freaking slop. I don't want any of this. I want to throw it all away. I want to undo what it did. And then figuring out a way to, okay, what's a better process to prevent that from happening?
I hear this term a lot more recently. That is the term guardrails. I don't know if you hear that in reference to AI. I think that is maybe people are starting to solidify around that as a way to describe what you're talking about. I kind of think of it as, if we're at the point that we're at right now, if you don't know what you're doing, if you're vibe coding, let's say, the AI could take you in one of 360 degrees, right? And infinite number of minutes and seconds within those degrees. Lots of different directions you could go. And you kind of want to, as an engineer, you know that there's kind of a general direction that this needs to go to be good. It needs maybe some guidance about what tech stack to use. Like if I'm at an organization that exclusively uses AWS or exclusively uses Azure, and I don't specify that early on, and it says like I created Lambdas for you or I created Azure functions for you, and it's like, whoops, like that doesn't fit this organization. Like they don't want that. They don't want to maintain that. They don't know how to. They aren't paying for that. Maybe they already have a contract with the other one. All of that stuff really matters. And if you don't get that stuff all specified early on, you kind of end up going off in a totally wrong direction that's hard to recover from. I think take 1,000 decisions like that in a row that go in the wrong direction, and you've got AI slop. So back to your point earlier, what are engineers for in the future? I think it's setting up those guardrails. I want this to be React. I want it to use this type of a routing system because I know I'm going to need that later. I want it to be hosted in this place, and I want deep linking. Those are things that the AI may or may not think about if you don't explicitly specify it. Later, it's always harder to fix it. So guardrails, I think, is the answer to your question.
Yeah. It makes me think of just the mental goal of hitting a home run. It come up and okay, here's a spec, and it's big and it's got a bunch of things, and all right, let me give it to Opus, and I'm going to come back later and I want it all to be done. It's like a million tasks and whatnot, and I want it just all to be there. It's going to generate more code than we even want to review. That's one mentality where, okay, I want to hit a home run. Then the other mentality is, no, I want to win this game just by hitting a bunch of single base hits, where every step of the way, you've got people on bases and you have more likely to actually get them home. And I mean, I think you and I have probably had the same business mentality of just, do a good job, take the next step, as opposed to, let me operate like a startup and get a bunch of VC funding and spend a bunch of money, and then it'll all work.
Yeah, right.
Like hit the home run versus the single base hit, and one step at a time. Because even if you fail, okay, let's just go back one step, as opposed to, shoot, I got a whole, but am I throwing away this entire 50,000 lines of code and starting over?
Yeah, I think the clickbait articles and the YouTube videos that you see right now, there's a lot of, OpenClaw and Ralph Wiggum loops and things like that, where people are, and so I was talking about spec-driven development before, spec kit. I think a lot of the stuff you see online about that is like, I wrote all my specs and then I went to bed and I woke up in the morning and this application was fully built. Maybe we'll get to that someday, but my experience is that no, that is not a good way to do it. So if you read my blog post, which it sounds like you did, if your listeners read it too, you'll see that I actually went user story by user story through it and very much watched what it was saying, even in those, sometimes 3 to 5 minutes while the AI is doing something. I would be reading everything it was doing, and I occasionally would say, I'd hit the escape key and be like, nope, you're going down the wrong path. Let me be more clear. Do it this way, not that way, and stop those things before they become a bigger problem. I don't know if we'll ever get away from that, but I think that that's the key right now, is definitely small steps. Take small bites so you don't choke.
Yeah, you do a whole lot of public speaking. When I talk to clients or an audience, I tend to find myself saying one of the same things. I say, all this AI tooling is going to help you do what you know how to do, but it's not going to magically do something that you don't know how to do. Are there any one-liners or any kind of just premises that you find yourself telling people, about how you think about how to align, how to use this new tool in your tool belt?
Yeah, I have a very similar line, which is that AI is an accelerator. It accelerates what you're doing. So if you're, let's say, vibe coding, you're not an engineer, you don't know what you're doing, it's going to accelerate the slop that you're going to end up with. You're going to get to slop a lot faster. If you're a careful, well thought out engineer, there's a much higher probability that you're going to end up with something good much faster than you could have done it yourself. I have a friend who's a lawyer, and occasionally I'll send him like, hey, does this legal language work? AI and I created it. And it's the same thing. He'll be like, well, there's parts of it that are okay, but it's like misguided. And that's basically a me problem, right? Like I don't know the law well enough to have guided it correctly. So yeah, it accelerates what you're good at to kind of mix what I say and what you say together.
Yeah. Awesome. Well, as we close up here, we'll include your blog and websites and even Beer City Code in the show notes. Is there anything else that you want to leave the listeners with, or let them know where they can see you next?
Yeah, if you go to our website, trailheadtechnology.com/events, you can see places that I'll be. trailheadtechnology.com/blog, you can see some of our thinking about things, and also put videos out on LinkedIn and podcast that I do as well called Blue Blazes, if people want to see me talking to some other guests about this type of thing. So lots of places to find me online.
Awesome. Well, Jay, thanks so much for coming on the show and chatting about AI workflows with me. I appreciate it.
It was really, really fun. Thanks, Jeffrey.
My pleasure. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.